Last class you were absent?
Sir, I don't know why, but suddenly, like, I'm being like very sick,
Oh,
like for 5 weeks almost. It's not stopping its effect. Like, it's affecting everything. Like in school, I also become tired because of that infection.
oh, okay. So like, if it is
Actually,
safe,
I have bronchitis. That's why.
okay.
But
So,
now it's completely gone. So that's why from today my attendance will be perfect.
okay, okay, okay. Take care of yourself. Okay, take care of yourself. Okay. So is it like a acute bronchitis, or do you have this
Yeah,
chronic condition?
I have acute bronchitis from
Acute.
childhood itself. That's why.
Oh, okay, okay, okay. For that purpose, there are some there's a obviously like you have to take medicines right now, but
Yeah,
particularly like you have to self care also. It can improve with self care, right?
yeah. I have a
But
very bad
proper.
habit of after playing drinking cold water, and that created my like. Actually, I have bronchitis every time, but
Hmm.
when I drink cold water, it becomes increased. That's why.
So simply avoid it, no, Ibrahim. Avoid it. It's not worth it going to the doctor, taking all that medicine, wasting your time over there. Uh, it's not worth it, no. So simply
Yeah.
avoid drinking cold water. In fact, if you're drinking cold water, so I'm guessing you must be drinking cold drinks also. You must be taking those soft drinks also, huh?
No, sir, I don't take soft drinks.
Okay.
Once in a while, I take only.
Yeah.
Once in a while only. Otherwise, I like ice
No, no.
creams as
If
well.
you're
Once in a while, I take.
don't even take once in a while. If you're suffering from this condition, make sure you avoid it. Avoid that. Okay, so I'll be quickly revising the concept which you have missed in the previous classes. Okay.
Okay.
Okay, you were there while we were discussing about lenses, right?
Yes, I was there.
Okay, good. So in the previous class, now we had learned about sunlight basically, like whether it is white or whether it is a mixture of different colors. Okay. Hey Halima. So there, what we have discussed that.
Hi sir, Assalamualaikum.
Yeah, walaikum salam. So the question here is that whether sunlight is white in color or whether it is a combination of colors. Mhm. Okay. So sunlight, what we have discussed, that it's a combination of all the colors of the visible light spectrum. It's a combination of about 7 different colors, right? And this was demonstrated for the very first time by Sir Isaac Newton in the year 1900. In the year
Yeah.
1665, it was described by him. So
He
what
even
he
made
had
Newton disc. He even
exactly.
made the Newton disc.
So Newtonian disk also correct. So what he had done, he passed the sunlight through a prism, which separated the sunlight into its components color, similar to the rainbow, right now. That is violet, indigo, blue, green, yellow, orange, and red in color over here, right? So when all these colors were to be combined together like that, so our eyes perceives the light as white. Like if all these colors were to be combined together, so our eyes perceive them as white actually, but in reality it has all the different colors of the visible spectrum.
It's
O-
just our brains comprehend it as a white because
Hmm.
that's how our retina can like absorb the light and reflect it back. That's why
It is not as simple as that. Okay.
the receptors mainly.
Our eyes basically, when all of them will be combined together, when if suppose if this spectrum of light were to be made to pass through an inverted prism, so all of them now combines. So this light which appears, which comes out
Then
of the inverted prism, so our light, our eyes, I mean to say, perceives this as white light. Okay,
Yeah.
that is the
sir
thing.
first, when the white beam of light, thin white beam of light,
Hmm.
just passes through a spectrum. I mean a
Prism.
prism.
Mm.
then it will become in different seven colors like white, indigo, blue, green, yellow, orange, and red. And
Yeah.
after
Yeah,
that,
actually,
then after that, when you again take the triangular prism and invert it, and
Mm.
then it will come back to its original shape like that.
Correct, correct. Right. Indeed, that is what happens
so
over
like,
here.
uh, Vibgyor, they say, I used to think when I was small, why do we call it as Vibgyor? Why not starting from red? Then I realized because actually when we have a prism, it actually divides it into the Vibgyor, our
It does
normal
so.
prism.
Exactly. But also, all these waves are actually arranged in the increasing order of their wavelength. Okay, now,
Yeah,
like red has the
red
highest
has,
wavelength.
yes.
It has the highest wavelength. Or
And violet
we
has
can
the
say
lowest.
we can say it as having the longest wavelength. That is more appropriate. Longest wavelength.
Yeah, longest wavelength means like its wavelength is weaker than the other ones.
Longest wavelength, it means that it can travel farther than other colors. That's why
Oh,
that's why red colored lights are used in traffic lights. They are used as signs of emergency
oh,
also.
like in lasers also, right?
Exactly. So suppose if red light were to travel this much of distance, for reference, I'm just telling you. So on the other hand, purple color or like the violet color will travel this much only. Getting what the difference here is.
So,
Oh,
and
okay.
the sky also is blue in color. That's why because of this reason.
Uh, yeah, this is also one of the reason where did told you
Mhm.
that the wavelength of the
Because of the wavelength, because blue actually manages to come into our atmosphere because of its wavelength.
no, no, it's not like that. It's not like that. You will get
Oh,
confused in that manner. One second. Okay, now it has got to do because it has a smaller wavelength and it kind of gets scattered by the particles of the atmosphere, by the gaseous molecules. I'll be coming back to that also, although we have discussed that.
okay.
Okay. See, so we have discussed about this thing, about how
Yes.
Newton proved that sunlight is actually made up of seven different colors via passing through the prism. He proved that. Okay. Then there was this Newtonian disk also, which when rotated at high speed, so it appears to be white in color, right?
So there's also, I remember, I also had a project when I was small to make a Newtonian disk, and when I
Oh,
tried it, it actually didn't work that properly because I didn't
okay.
have the specific colors. I didn't
Hmm.
have the specific colors.
When I was in your grade, I too had that activity. Okay. So,
In my class, when I was like in five or four or five, fifth grade,
hmm,
then that time my teacher told me that you have to bring a disc. So I had a
okay.
disc. It was like a rainbow color, and
Hmm.
then she showed me. My teacher showed me that activity. Like you are supposed to make
Uh,
like
Sir, it
spin
was
it
fun
very
still. It was still fun.
yeah,
But nowadays,
and
like
you
compact
supposed to
discs are not
spin
even
it
used.
fast.
Hmm.
And then some of my classmates were very shocked, and then they thought
Okay.
it's a magic.
Okay. Okay. Okay.
Yeah, sir, like it was the same thing for me. Like I was like, how's it changing color when you were just spinning it?
Good. Good. In fact, like I had this project. I don't know whether it was in seventh or eighth grade. So I had made a model of the solar system, right? So where all the planets they were orbiting around the sun. I had fitted lights and I have used electronic equipments and motors and all that. Okay.
Oh,
So
motors for the spinning of them.
yeah, yeah. So all of them are basically rotating on their orbit, right? And like the sun, what I had done, I took a plastic ball in that I made a hole and I inserted a ball inside that, and I took some cotton, I painted it yellowish in color, okay, and I pasted it all over that ball to give it that effect. Okay, on the sun,
Oh,
I'm seeing the model of the sun. It was like that. So it was really interesting. Okay, and there were ton of other activities which we used to do in the school. Like we had used to
yeah.
have science exhibition. Okay. Hey Ayush.
Yeah,
Okay,
sir. I also have science exhibition and I'm doing a project too for that.
good, good, good. There are so many interesting ideas I can suggest you for science exhibition. Okay, there's so many.
I thought about piezoelectric generation. That's why.
Sir, yesterday
Oh,
my science exhibition also.
oh, you also had this exhibition in your school. Oh, that's really good.
Yes.
When did you participated in
So
something?
like,
Yes, I participated.
Okay.
Sir, I had
What
a math exhibition, not science.
math exhibition? Okay, good,
Yeah.
good.
So in that,
oh, that's interesting.
so we had to make a building using some blocks, Legos, and all like that.
Oh, okay, okay,
And
good.
some people made a road.
Mm-hmm.
Um, I was also there. So I made a road using some solar equipment like that.
Mm. Good, good, good.
Oh, you mean those? Okay, okay. So, like, sir, I also made piezoelectric shoes. Now I just
Mm-hmm.
need to connect a port and add the Arduino. That's it.
Oh, okay, good, good.
Because
You
we
can
actually
make.
want to control it. We want to control the voltage that the Arduino is going to send to ground. Because we
Mm,
also want it to like generate the electricity we want.
good. By the way, you guys can also like if sometime in future you can work on automatic street lighting system also using the LDR technology, right? So
Yeah,
using the
LDR. It's a it's like very
l-
famous. They're used in cars also. Like
yeah.
they're able to sense everything on the road. They're
Hmm.
better than cameras. They're better than cameras at sensing
they
people.
can they can sense light right now. So
Yes.
basically using the LDR technology like
Yeah,
light dependent resistor, you can use sensors in it that will be turning on that will turn on the lights automatically at night.
turn on automatically. When a
Exactly.
person passes through, and then the light just ons automatically. And when the
Hmm.
person just gets off from the light, it turns off.
Exactly, it's
I
like
do
that.
have lights at
Hmm.
home.
Suppose this is a street light, suppose like over here, and if someone is passing by like that, so when someone comes nearer to it now, okay, like suppose this one is passing.
Yeah,
So if
I
someone is
saw
near,
the I
it will
saw
turn
one
on.
of the lights. I saw one of the street light in some park, I guess. Yeah.
Hmm. Good, good. Well, you can also make some smart irrigation system. Also, you can work on the model of
Yeah, we
seismograph.
they use
Also,
special motors.
uh,
Like last year when I went for my PTM, a girl she made a auto, like she made a mini fire system which would
okay.
release water, and it used an Arduino Uno R3.
Mm.
That's the second newest version of Arduino
Good, good.
Uno.
Ayush,
Yes.
what did you work on? You had a exhibition. Tell me.
So I made like a save water for agriculture resources. Technology to save water for
Okay.
agriculture resources.
Good, good,
Oh,
good. Very good. Okay. So there are so many ideas. There are ton of
yeah.
ideas right now. You can make a model of seismograph also that demonstrates how
Yeah,
earthquakes are
like
detected
the earthquakes are detected. Yeah,
using
I
the help
remember.
of this.
I remember. I used to think, how does it even make sense? Like, how will it move up and down with just the Earth's
Mhm.
movement, and how is it so accurate?
Basically, what happens? There's a rotating drum like that. There'll be rotating drum.
Yeah.
Over
Yeah,
that, there will be a
but
pen
it-
mounted like that. Okay, now there'll be
Mm-hmm.
pen, and there'll be graph paper on it, right?
yes,
And
graph
say
paper.
that this is mounted
And
on a stand.
whenever the earthquake happens, even if it's slow or more faster earthquake,
Hmm.
still it can
No, you should not say faster. You should say like the magnitude of the earthquake is higher,
Intensity, you should be saying higher intensity or less intensity. Intensity.
or higher magnitude or less magnitude.
Like that. So what will happen? Suppose, like, if you were to make a seismograph, so you will have a setup like that. Okay, I will show you the image in sometime in class. So
Oh,
this will
it
be a
looks so
rotating
nice.
drum. This will be a pen. Okay, and that will be a stand. You will manually shake it. Okay. So what will happen? The pen will start to make line graphs on it like that. Okay, na?
That's a line graph. That's called a line graph.
So this is later on analyzed. Okay, na? And then the value is displayed on a Richter scale, right?
Yeah.
Okay, like
so
that.
Actually, this
that
is the
will
easiest
happen.
part. This is the easiest part.
Yeah.
The rest part is analyzing it.
Yeah, yeah, Halima, you were saying something?
So that will this movement of the pan will happen till the end of the earthquake.
This moment of, please repeat again.
Sir, this movement of the pen,
Hmm.
it will do on the graph, right? So
Yeah,
this will happen till the end of the earthquake.
exactly, exactly. It will keep on
Oh.
plotting till the earthquake stops. Right now,
So,
that is the
sir,
thing.
how, like, there's only one piece of paper. How can you do like the whole thing?
It's a really long piece of paper, and like the setup which I have shown here, it's a pretty big diagram. And earthquake basically lasts for a few seconds to minutes only.
Yeah,
Earthquake does not
like
last long.
the largest ones almost were in Bengal. Like the last, no, not in Bengal, but like it's almost the largest one is like almost 10 minutes only. The largest
No,
one.
it can't be 10 minutes long. It will be very devastating. So typically, it will be from few seconds to couple of minutes only. Right now,
One or two days,
average
that's it. Right?
average earthquake lasts between 10 to 30 seconds. However, the duration of the shaking can be a bit longer, and it also depends upon the magnitude of the earthquake also, right?
Yeah, the higher the magnitude, the like
More will be the shaking of the plates
yeah,
and the
more
ground,
will be-
right? The
yeah.
larger the earthquake, the longer it will be lasting. That's the thing. Okay, so further in the class, we had discussed about the formation of the rainbow also, like how the rainbow was formed. So there are some conditions required for the formation of the rainbow. Okay, so let us understand about its phenomenon first of all. So during the rainfall, particularly during the rainfall, if it is raining and the sun is also there low in the horizon, sun is not over your head, but it is low in the horizon like that. Okay, so what happens as the sunlight will be passed through these raindrops? So these raindrops acts as glass prism. They act as glass prisms. So what happens
Because they're
as
transparent.
Mhm. As you guys can see here, light is entering into different medium. Earlier it was traveling in air, now it is traveling into water. So medium is changing.
Yeah.
So you guys remember, if you, suppose I have this
Diffraction. Diffraction.
uh, suppose for example I have where to take some water in this. Okay, and in this, let's say I'm going to dip something. Oh, 1 second. Okay, suppose I have
Oh,
taken a
sir.
straw and I'm dipping in it. So while I'm looking, okay, I don't know how whether you guys can observe it, but as I'm looking it, so I am seeing that the
Yeah.
straw
It's
appears to be
bent
bent. Are you guys able to notice that?
because of refraction. Because of refraction.
So the straw appears to be bent. So basically, light rays have actually bent here. Getting it, everyone? Light rays have bent here, and the phenomena of refraction happens here. So similar kind of thing happens here also, where the rays of light bends. And you know that white light is made up of 7 different colors now. So it will
Yeah.
bend into 7 different colors, just like how the light rays have bent here. Just how it is bending. Light ray was going like that now. See, this was the path in which light ray was going, but here it is now bending into different
Because of
colors
refraction. Because of
because of
refraction.
diffraction. So diffraction has happened here. Now all these different colors of light now, violet, indigo, blue, green, yellow, orange, red, all the way
They
from violet
reflect
to red,
on the due
reflect
to the
from the
surface tension of the water. They bounce back due to the
that,
surface tension.
yeah, we
So,
can see that also.
for this, um, there are some conditions which,
We will get back to that also. Okay.
yeah.
There's some conditions you're mentioning
Yeah,
correctly.
probably like it should not be acid rain, maybe because acid rain might disrupt the
Those are the other considerations, other things. Main things we'll be discussing. So look over here, what
yeah.
is happening here. All these rays of light are now getting reflected from the internal surface of this raindrop. Okay, so
Okay.
internal reflection is happening within the water. Reflection is happening. Okay, now
Mm-hmm.
you see all these rays of lights are now exiting here now. All of them are
Mm-hmm.
To the
exiting,
object.
leaving it.
Mhm.
So they are going into different medium now. Right now,
So
right now
that
they were traveling.
rays of light
Yeah.
inside the raindrop, it's gonna reflect and then it's gonna refract, right?
Exactly, it gets reflected and it gets refracted again as it is changing a medium. From
Yes,
water
it
it's going
Yeah.
into
refracts.
the air, so it refracts again. So that is what you are going to see in the air, in the sky, I mean to
Yeah.
say. Right now you can see
That
the
like
red and
it's
all
kind of
different colors.
like it's kind of like it moves at the exact opposite way of what.
You guys please read this. I just forgot I have actually placed something on the induction for cooking. It will burn if I were not to lower it. 1 second, I'll be back in a minute. 1 second.
Okay, so why doesn't it work for my laser?
There's a
Oh yeah,
condition.
maybe. Oh yeah. There's also another condition.
It should
You
be
just
like the sun should be low in the
yeah. It should
horizon.
not be a. It should not be a red light probably because I have a red light or any other color. Uh, let me see that. Oh, it acts like a convex lens. Wow. Oh.
So
Let me give you more bigger. Let's turn it. I mean, it's not amazing, obviously.
not me.
Why does this light even change its color?
Yes, I'm back.
Sir, I have some dish-like piece, and I wanted to ask, like, sir, I have this dish-like piece, okay?
Well,
This
let me zoom
dish-like
that.
piece,
1 second. Let me zoom it out.
like
Yeah.
this dish-like piece.
Mm-hmm.
So, like, sir, when I took my laser, it's red in color, and I pointed it in like this. Why does it like create a glistening effect? Like it glistens. Like, how will I show you? Yeah, over here, when I point this it at over here, it glistens a bit.
Okay. Move it up. Move it up.
It glistens.
Okay.
It looks much different from like this and like this. They look different.
If you
It's
can,
because of the
if you can move that sheet a bit up, I can see it better then.
okay.
Oh.
So like I put it over here, and then I take this, and then I point it at, and it
Mm-hmm.
starts glistening. Like on the sides, there's some dim light coming. I like,
Okay.
but it does. So does this affect the focus of the red light?
No, no. Basically, what is happening here, like the shape that you are having here. Okay. So that is a
It's like
concave
a
shape.
convex lens. Yeah,
Concave. It is having a
yeah.
concave shape. Okay. And like it is kind of a concave lens, we can say, although it's that is not a proper lens. Okay, because it is a colorful piece of
Yeah.
fiber plastic or something, right? So through which light is
Sir, but it
passing.
creates the same effect when I keep it like this. It creates the same effect.
See, basically, the property of the concave lens is that it disperses the rays of light. Although the image will be formed, but it won't be a sharp image. So it will be basically dispersing it now. Getting it? So
Yeah,
concave lens always diverges or spreads out the parallel light rays. You are projecting a parallel ray of light on it now, and you're projecting at particular at the center, right? So it is forming an image actually. The one that you're showing me on that sheet, so it is forming a image, which is a diminished image, right? And which is not a sharp image. Okay.
yeah. But it's the same thing on the other side. I guess it's probably because of the type of plastic or something we're using for this.
Yeah. See, basically the basic concepts that we learn over here, they're kind of straight and simple, and basically they work only when proper when they are tested, when the laws are tested upon the proper material. If the materials were to be changed right now, so there will be slight
Glass is the
variations.
most important one.
And the object that you're seeing, that is not the standard material to study about the properties, like the laws particularly. Getting it?
Because it's much different. It's plastic. That's
Different,
why.
it's plastic, it is colorful object. Okay. Getting back to this thing now, so there are some conditions required to see the rainbow. First, sun should be low in the horizon, like it should not be just above, not overhead. Okay, Ayush, Halima, and Ibrahim. Then observer must be standing in between the sun and the clouds over here.
Rainbow. I
Rain,
mean,
rain, I mean to
I
say.
have a
Yeah, Halima.
sir. When you says when you say that sun should be low in the horizon,
Mm-hmm.
so should it be the time when it's going down? Like,
Sunset, you're saying?
yeah.
No, it should
No, like
not. It does not necessarily have to
after
be sunset.
before evening
Uh,
almost.
like you can say around like 2 p.m., 3 p.m., like that. You can say.
But it not,
Yeah,
but
like
it
at that time.
not be above our head.
It should not be directly above it. Understanding that, because
Just like slightly,
as I
slightly.
as I had said, like one of you, or like only one student was present in the last class. I think it was only Ayush.
I was thinking,
You were there, no? Oh, okay.
yeah.
So say that if this were to be position of the sun, so sun rays are going to fall on the raindrop like that, right now.
Mm,
So
And
will
it's
the
not going to
rainbow
be
form?
efficient.
A
No,
rainbow
the
will
rainbow
not
won't
form
fall in that.
exactly.
It will just bounce back in the
Mhm.
other direction, like upwards, in
Uh,
a upward slanting direction.
exactly. So the light rays will be refracted back into some other direction. Okay, then sun
Yes.
should be behind the observer. Like the observer must stand in such a position that the sun is behind the observer. Like the sun should be over here.
Yeah, because the effect of refraction and reflection cause like the same effect. So it's gonna be directly. It's gonna be so like the person will be
See,
able to see the
basically,
rainbow
basically the thing
directly
is that
behind
from
under
this
the sun.
from this direction, the rays of light are going to fall over the water droplets. After refraction, this is where the refracted rays of light are going to fall. After refraction, this is where they are going to go now, right? So
mm-mm.
observer must be standing right over here in order to see this, right?
Yeah.
Like that. So these were some conditions for it.
Whenever the rain happens,
Hmm.
uh, then the clouds always cover the sun.
Yeah, it does, but many times not. But usually, whenever this rainfall, the sun is covered by the clouds.
But why does
Yes.
that happen?
That's why rainbows are kind of rare. That's
Uh,
why rainbows are
ha,
kind of rare.
Yeah, Halima,
We
complete that.
won't see that in India. We won't see rainbows in India.
You won't see that. No, no. You can see rainbows here in India only. Here in India also, I mean to say, if the conditions are
In
suitable.
Kuwait, I was quite lucky when I was small in like 5 years old. I saw a
Hmm.
rainbow in Kuwait.
Hmm.
Like I can't,
Oh,
like
Okay.
I saw it in a manga. Like their rain is, I guess, comes frequently.
Okay. Usually, if the conditions are suitable, in most of the places, rainbows can be observed, except for some places. Right? If the conditions are right,
Obviously, and obviously there should be
uh,
rain.
there has to be
So if there
presence
is
of
no
water
rain,
droplets.
but sir, whenever rain occurs,
Hmm.
I mean, the clouds always cover the sun. Like, not always, but like sometimes. Why does
Hmm.
that happen?
Why does sun get hidden by the cloud? See,
Yeah.
because simply clouds are dense now. Actually, clouds are dense, so they will not allow the sun rays to pass through it. Understanding the clouds are like
yeah,
they're
because they
actually
actually
dense.
contain a lot of water and
Uh,
hydrogen and other atmospheric things. Like
gases
they're
and
very dense. They're so people think clouds are like in cartoons they show clouds are fluffy and all of that, but they're not. They're like very dense. They say that
in fact.
a
Hmm.
cumulus cloud, which is one of the smallest clouds in the world, it
Hmm.
weighs a whole elephant if we
Hmm.
do not soak it with water. But when it's soaked with water, it weighs 18 elephants.
Just figure it out, like how dense and how uh,
Exactly, that's what.
huge it is, right? So rain clouds, they are particularly large, they are dense, so they will obscure the sunlight, they will stop the sunlight, and that is why they make the sky appear darker also, right now. So they are thick, they are filled with water, and they block the sun's rays from reaching the ground. That is the thing. Okay, then we had learned about this interesting phenomena, that why the sky appears to be blue in color. Okay, what we have
Yeah.
learned, yeah.
Because blue light scatters away, and
Hmm.
because of that, the atmosphere becomes blue.
Hmm. Hmm. So basically,
So is it because of the ionosphere, like the ozone, the ozone layer?
No,
Yeah.
it is not necessarily of the ozone layer only. We can't say it like that. Basically, molecules in the atmosphere, no? Like here in the atmosphere, you have molecules of different gases. So they scatters all the light rays, but not all of them are scattered by the same amount. Right now, light of the shorter wavelength, like light of the shorter wavelengths, particularly
Why not purple?
like
Why not purple?
one
Like,
second,
I mean violet,
they are also that is also scattered. So light
but
rays
very
like
less amount.
one second, let me complete that. So light rays, no, like blue, violet, they are scattered more easily. Right now, they are scattered more easily. Getting it? So violet, indigo, blue, they are scattered more easily. So because of this scattering effect, no, because of the scattering effect, we get to see that sky happens to be blue in color. Okay, no? So
Uh,
so they are kind of getting scattered. That is the simple reason. Okay, so whenever sunlight enters the Earth's atmosphere, it will kind of collide with the gas molecules present in the air.
so they will
Particularly,
just like break
maximum,
up. They will break up.
we can't say it like that, that they break up. No. See, particularly they collide with nitrogen gas, maximum amount of gas in the
Nitrogen.
atmosphere, nitrogen gas. Then next they collide with oxygen gas. Okay. So as they kind of hit these gas, so what happens? These molecule will scatter the sunlight in all directions. However, they scatter shorter
Because
wavelengths
they're
of
very
light
light.
more. But
Because they're very light.
it is also not like that. Which not
No,
only
photons don't have mass. Photons
how
don't have mass.
that is one of the reason we can say okay, and the amount of
Scatters
scat.
more light.
Mhm. And the amount of scattering really depends upon the size of the wavelength of different lights over here. So there I
Oh,
told you
okay.
that these lights are like the blue, violet, blue, indigo, they scatter the most. That is why they together also, even though the violet light is scattered more than the blue light, but our eyes are actually more sensitive to the blue. Getting it?
Because
Suppose
of our,
in
because our, yeah, because of
if in front
this.
of you, if I were to show you two spherical balls, one is violet in color, one is blue in color, your eyes will be more sensitive to the blue color ball. Getting it,
Yeah,
guys?
we won't be looking that much to the violet color ball.
uh, so even though maximum scattering of violet takes place, but your eye is more sensitive towards the blue color. That's why the sky happens to be blue and not violet. I hope that is clear to everyone.
Yes, sir.
So there will be one more addition I'll be making here. Our eyes, even though violet light scatters the most, even though violet light is uh, scatters the most, our eyes are more sensitive to blue. Okay, hence this makes sky appear blue to us and not violet. Okay, now we are in a
Mhm.
position to do some questions. Okay, I'll be needing
Okay,
just
yeah.
one more minute. I just have to turn it off. Okay, then we're going to
Okay,
continue.
so yeah, finally questions.
So should we do it in a notebook or oral?
No, no, no. It's going to be oral probably. I
Oh,
guess so.
sir is not there.
Yes, I'm back.
No.
Okay.
So an image that cannot be obtained on a screen. What kind of image is it?
Mm-hmm.
Virtual or erect?
Uh, erect.
Erect. Erect.
Sorry, virtual or real? My bad. Virtual or real?
Virtual.
Virtual. Virtual.
Virtual.
Virtual.
Okay.
uh, Next.
So can we go in an order?
Yeah, that will be better. That will be better. Good idea. Okay. So Ibrahim, then Ayush, then Halima, then again Ibrahim, Ayush,
Okay.
Halima, like that. Sorry.
Okay, sir. Okay, image formed by a convex lens is always virtual and smaller in size.
Okay. Next, uh, Ayush.
Ah, this one.
By the way, you saying mirror or lens? You said lens, no? You
Yes, I
said
said
lens.
lens.
No,
Yeah,
no, no.
lens.
That is correct.
Oh yeah, mirror.
It's mirror now. Image formed by
Yeah,
a convex mirror is always virtual and smaller in size now. While the image formed by a concave mirror, what we have
yeah.
discussed,
Now
it
I
depends.
remember. Yeah. I'm sorry, sir, for the like
No
mistake.
issues. No issues. Okay. So in the case of concave mirror, we have observed that the nature of the image depends upon how far the object is standing in front of this.
Yeah,
This is the concave
more
mirror.
farther away, the more it also will look more diminished.
So it really depends where the object is standing. Okay, like this is
Yeah,
called as
it doesn't
focus,
depend on many
center
things.
of curvature. Whether the object is standing over here, whether it is standing over here, whether it is standing over here,
It
or whether it is
depends.
standing at infinity.
It
Infinity.
depends on wherever the object is standing.
Hmm.
If it is standing at like the end, or in front, like more closer to the end.
If
I
it is
mean,
very
closer.
closer to it, if it is between focus and the lens, sorry, mirror,
Yeah,
then in that case a virtual image is formed, and which is enlarged
yes,
like that.
Yeah,
yeah.
Okay.
Because the light moves, scatters like in this
uh,
direction. Like it was
and
first
then
like this, but then goes like this.
Hmm.
So our brain it perceives it as a large image as the angle creates a large image. That's why.
No, it is not simple like that. Okay, there are some rules for it
Like
to understand.
because like I've heard that the angle of light also matters in
Yeah.
seeing something.
Okay,
it
but
does matter.
it does, but there's some other
Like if
things
the
also.
angle is like this, we
In
will
other case,
perceive our receptors will perceive it as a larger image.
I have one
That's
question to all of you. You guys tell me, in your school, have you guys been taught about the ray diagrams
ray
of the light formation by mirrors and lens? Because
no.
it isn't in the syllabus actually. So while in some school, teacher actually teach it especially. That's why I'm asking.
Oh
If
no,
it
sir.
isn't, then
We don't have any problem.
We,
We don't have any problem.
okay, okay, no issues then.
yeah,
Okay, actually, there are some laws also. Like, suppose this right over here, this line
Laws
here.
of reflection.
In 1 second, let me just add few points to it. I'll be allowing you guys to speak. See, so basically, this line here is called as principal axis. Okay,
Yeah.
you'll be learning about that in detail in higher classes. Principal axis, principal, principal, principal axis. Okay, this the middle is called as pole. The middle here is called as pole. All right. So when a ray of light will pass parallel to the principal axis, now it will reflect back from the focus. If a ray of light passes parallel to the principal axis, it falls parallel to the principal axis on the mirror.
All the
It
time.
passes
All the
from the
time.
all the time. Okay, like that. Then there are some other rules for it also. Right now, suppose for example, like this one is simple. If a ray of light were to pass at the pole, it will reflect back like that, and this angle will be equal to one another, following the law
Yeah.
of
Law of
reflection.
reflection. Law of reflection.
Correct. Okay.
So the
And
law of
suppose
reflection is suits the concave lens. That's what we
it's
can
not
say.
a lens, it's not a lens, it's a mirror.
Mirror.
Hmm.
Yeah.
Also, suppose if a ray of light were to be incident from the focus, if a ray of light is passing such that it is passing, 1 second, Halima, if it is passing through the focus, it will return back as parallel rays of light. It will return
Oh,
back as a parallel ray of light that will be parallel to the principal axis. So these are actually some of the laws that you guys will be studying in the higher grades. That's why I'm not going to touch this topic, otherwise you guys are going to get
it's pretty
confused.
interesting.
It
Like
is.
everything is makes so much sense. Like when you first told us about the first property, it
Hmm.
meant that if it was parallel, it would hit the focus. The ray of light will be over the focus, and it's the complete reverse. Like
Hmm.
if the ray of light is at the focus, it becomes parallel.
Parallel to the principal axis. Indeed, it is.
So
And
that
also the
so
size
by
of the
itself,
image. One second, one
so
second.
by itself. Okay, okay.
Mhm. Also, the nature of the image that we get to learn about, no? It also actually depends upon how the rays of light get reflected and meet at a point. Like, consider the same example. About the concave mirror, what have I told you? That a concave mirror can form image of the same size. Image can be larger, image can be smaller. Suppose that
It can be also virtual or erect.
virtual and
Sir,
erect
you
also.
can give the answer for this
Yes.
third one.
It will be
Repeat.
erect if it is between if the object is between the focus and and the mirror
Huh.
and the
It will
concave
be.
mirror.
It will be virtual also. Correct. One second. Let me just complete that. That is focused at the center of curvature. And the C is for center of curvature. If an object were to be standing at the center of curvature, okay, now if it is standing at the center of curvature, let me just
What is
complete
the
that,
center
everyone.
of curvature?
Like, I'll be getting back to that in a while. One second. If
Okay.
a ray of light were to fall parallel from here, okay, getting it. So what will happen? It will get reflected from the focus. It goes like that. Getting it?
Oh.
Then from this you take another ray of light. Sorry. If there's another ray of light that is passing from the focus like that, so it will be bouncing back and it
Parallel.
will parallel go back parallel like that. So now you see you're having a point over here. So this is where the point will be there, and you're going to make an image like that. So this image is same as this object size. The size of the image is same as that of the object, and it is inverted, meaning upside down. Okay,
Oh,
na?
that's amazing.
Inverted. So the different nature of
So
the image
that's how
that
it
we get to
works.
learn, that is how it exactly works. Whether the image will form will be inverted, whether it be
Because of these things,
Mhm.
like the light changes their own positions, so it becomes
Huh.
inverted.
Okay, no? So that is the thing over here. All these things are
That
actually in
always
accordance with the law. Mhm.
It's
that
pretty
always happens
amazing.
in convex or concave or a plane mirror.
For
Like
different, see, there are some general rules for formation of image by the plane, concave, or convex mirror. It is in accordance with some law. Okay. Like when you will
okay.
learn about that in higher classes, no, they'll be learning about that in detail. That's why I'm not touching this topic. Otherwise, if you guys were to continue studying with from me, like in higher class grades also, so surely we'll be learning about that too. Okay.
Okay.
Right now, let's stick to the syllabus.
Inshallah,
So,
inshallah, sir, we will be with you in higher grades.
okay, inshallah. So, over here, the next question was assigned for you, now. It was you, Ayush.
Yeah.
Yeah. Then Halima. Yes, Ayush, what's the answer? An image formed by
The
dash mirror
same
is also
question
the
or
same
what?
size as that of the object. Which mirror will always form image of the same size as that of the object?
Sir, can I try answering?
No, 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 let him answer. You answer
Okay.
yours.
Okay.
Meanwhile, Halima, you can also answer your question, like question number D.
So um, an image which can be obtained on screen is called a virtual image.
No,
Sir,
it
It's
is real
erect.
now.
It's called
Oh
an
my bad. Real, real.
Real now. Yeah, Ayush.
sir, did you ask something to me because I was like, I
I
want
was
to
saying
assure.
answer question number C. An
An
image.
image from a
Mhm.
plane mirror is always of the
yeah,
same
that's
size as the
Exactly.
object.
It is very good. Okay. Ah. So for this Halima, it is going to be a real image, right? Real
yeah
image.
because
Like, try to memorize it in the following manner, that the rays of light are really meeting at a point. Okay, na? The rays of
Yeah.
light are really meeting on the screen. So hence real image is formed there. Getting it? Na?
Yeah.
Uh, or
Yes.
like for example, we say that you have heard about virtual reality or virtual world, words like that,
Yeah.
Yeah.
right? You are living in a virtual world. So the image, your image that is formed in the plane mirror, it's kind of a virtual image, right? It is not actually
It's
formed
not
on the
true.
screen. It's not like the rays of light have actually met at a point. That,
It says it is obtained on the screen, so that is not virtual image. It's a real image.
any image obtained on a screen, that is a real image, like the image formed by the projector, like that.
Yeah.
Like virtual reality,
Hmm.
like they put like the phone. It is like when we use a phone inside the virtual reality headset, it actually doesn't meet at a point.
Hmm.
They're just technically
Huh.
just on the
Hmm.
mobile something.
Hmm. Okay, move on to the next question. Yeah, Ibrahim. Then
An image formed by a
Sushil.
concave mirror.
Ayush. Sorry, Halima. Then
So
Ibrahim.
I
Image
think the
formed by
answer
a
for E question, concave mirror.
concave mirror.
Mirror.
No, 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 no. It is saying an
Oh,
image
okay, so
from a
it's lens.
concave
Right.
lens cannot be obtained on a screen now, because
Okay.
you know that there's only one situation where in the case of concave mirror a virtual image
Because if
is
it's
formed.
between the focus or the focus and the lens,
Mirror,
only that time.
mirror. When the
Yes,
image object is placed between the focus and the mirror, only in
it
that
becomes
situation
virtual.
a virtual image is formed, while in every
Yeah.
other situation a real image is always formed, right now. So an image formed by a concave lens cannot be obtained on a screen actually, because it always
Okay.
forms a virtual image only. Okay.
Only.
Okay.
Next.
Oh,
Oh.
Yeah, Ayush, answer question number A. We can obtain an enlarged and erect image by a convex mirror.
Sir, false.
It is false now, because it always
yeah.
forms a diminished
False.
image.
Because only it only happens with concave mirror.
Hmm. Okay, that also actually depends upon whether where the object has been placed. Okay.
Yeah.
Next, yeah, who's there? Halima, right? A concave lens always forms a virtual image.
Concave lens.
Yeah,
True.
Oh,
True,
wait,
sir.
wait, wait, wait.
it is true indeed. Right? A concave lens always forms a virtual image only.
Okay.
Okay.
We can obtain a real enlarged and inverted image by a concave mirror. That is true.
Correct. Yeah, Ayush.
Yes, sir. A real
Mm-hmm.
image cannot be obtained on a screen. It is false, sir.
It is false, because the very
Yeah.
definition is that it can be
Concave,
obtained on a screen.
a
Yes.
concave mirror always form a real image. Concave mirror.
Hmm.
So
Uh,
yeah.
wait. It's uh,
Again, we are to the
So
same question. Concave mirror.
it's
yes,
yeah.
concave mirror.
True.
It's saying
Or
always.
not
No.
Oh, my bad. Not
it
always. Not
only
always.
between the
But
focus. Only between the focus and this it can also cause a virtual image. So
Hmm.
that's an exception. So that means it not always creates a like a real image.
See, concave, concave mirror, ray diagrams.
Oh, the
oh
concave
yeah.
lens looks like a boomerang.
Hmm.
It looks like a boomerang.
Yeah.
Question was about mirror or lens? It was about mirror, no?
Yeah.
Yeah. Mirror.
This one is actually
So that's
lens.
why between the focus and the lens, a virtual image can be formed. So thus, it's that's an exception.
Hmm. I'm trying to take a relevant image over here. One second.
So there's no relevant image for a mirror. It's only for lens.
Hmm. No, no, no. There are some. There are some of them actually. Okay, let's say this one I'm taking here. Suppose. Okay. See. Look over here. If an object were to be placed over here between the focus point and between the mirror, right? So then the image will be formed behind it. Then the image will be formed behind it. Getting it? So always keep in this thing in mind that whenever an image is formed behind the mirror, any type of mirror, it will be always a virtual image. Whenever I'm seeing that image is formed behind the mirror, then it is always a virtual image. Understand that everyone? Like the object will be placed over here, and the image of that object will be formed over here. And this case, it is enlarged also. It is enlarged. It is
And for this,
virtual and
the
erect also. Yeah, Halima?
so for this diagram, this is for concave mirror, right? So it is going behind it, so it's the real image.
No, no, no. I'm saying that when like the rays of light are not actually passing through it, we are really basically plotting it. Okay, na? There's only
What?
one situation in the case of concave mirror when a virtual image is formed. And that I'm saying that when it is placed over here, let me show that draw it actually, then you guys will get it completely. 1 second. Um, okay, hold on. See that this is the concave mirror. All right, this is concave mirror. This right over here is your principal axis, that is focus,
Yeah.
that is center of curvature. Okay, suppose this is where the object has been placed between focus and between the mirror. Okay, so what will happen? A ray of light is going to pass from here. 1 second, guys, please. A ray of light is passing on it like that. So thereby what will happen? It will get reflected like that. Now from the focus, it will reflect back. Okay, from the focus, it reflects back. Another ray of light goes from here like that. Okay, and then it gets reflected back like that.